Hi, my name is James Katlangal. I'm a senior application scientist here at LI-COR. So today I'm going to talk about how to set up a basic measurement with an 8250 system. So here I have an 8250 system with two gas analyzers. I have an 870 on my right side and a 7810 on my left side, and I have one long-term chamber with me here. We will do the initial setup in the lab, and then we will go out and do a simple measurement out in the field. All the devices are now connected, and we are ready to do the setup of the setup in the software. To do a setup on an 8250 system, we will use the web browser here. I'm going to connect to the system through the Wi-Fi network available on my computer. So I'm going to open the Wi-Fi settings here, and I connect to the Wi-Fi network which is named after the following the serial number of the 8250. So you have to use a security network security key here, and it will be LI-COR ENV. So once the connection is established, I can connect to the device in two different ways. One will be to enter the serial number of the device in the web browser, or to use an IP address. Sometimes we'll have issues resolving the host name to the IP address, so it will be easier always to use that IP address. The IP address in this case is 192.168.46.1. So once you put in the IP address, you have a direct connection with the 8250 system, and the device networks actually shows whatever device is in the system now. So here you can see I have a trace gas analyzer, which is the TG1001029, which is a 7810, and then I have an 870 which is connected to this multiplexer, and I have a chamber connected on port 8. So all the devices available in this ecosystem will be shown in this device network. To configure a measurement, we go to the configuration tab, and as soon as I go there, you can see the 870 is automatically added. If an 870 is present in the system, it will automatically be added to that configuration. Here we use this very simple drag and drop system to program the 8250. We have different choices on the left side, and we have a programming environment right here where we can drag and drop different components and make up our measurement sequence. So this one says the 8250 multiplexer is here, and we have the 870 gas analyzer connected to it. So we were going to add the 7810. So we go to the gas analyzer tab here, and then we pick the 7810 and drag and drop it here. So it's really easy to drag and drop. Once you have that, you can go to the host name, have this drop down, and pick the 7810 which is in that network. So we already know that it's there, so we select that. Make sure to enter the tube length in this case, which is the tube which is connecting the 7810 to the 8250. And if you have a T fitting, make sure you include that length also in this, along with this tube length, to account for that extra volume. So the tube length in this case is 120 centimeters, and I have extra 30 centimeter of the T fitting, so I'm going to add that in this one, so it's 130. You can have different tube lengths depending upon your configuration, so make sure you measure and enter that tube length in the correct format. Make sure it is the one-sided tube length, because you have in and out, but we only have to put in the one-sided tube length here. So once you have the multiplexer and the analyzers set up, now we have to add our ports. So we add the port, and to the ports we will add the chamber. We can add up to 8 ports in this configuration, so you can actually right click, duplicate this, add one more port like that. It should be really easy to do that. Or in this case we only have one chamber, so we just need only one port. So I'm going to delete that one here, and I'm going to add that chamber. In this case will be a LI-COR chamber. So I have different choices. We have the long-term chamber and the clear long-term chamber here. I have the long-term chamber, which is the opaque one. I'm going to drag and drop it, and I'm going to choose the right port. Here I have it connected to the port 8. So as soon as I select the right port, the software recognizes the serial number of the chamber, its firmware version, default tube length, which is the 15-meter tube length, and the other settings also come up here. So at this point I can decide how to do a measurement. Typical measurements are on the order of 1 to 2 minutes. Here we will do a 2-minute measurement cycle. So that will be 120 seconds, and then we can have a pre-purge and post-purge. These are essential for chamber measurements, so that we can purge the lines when we go from one chamber to the next chamber. We can keep the pre-purge maybe 15 seconds, and post-purge also 15 seconds, and the observation length is 120. We do have options to put in the latitude and longitude of the site, which is the location tab here, and we can also figure out the how far the chamber has to open when it's done with a particular measurement. This is how to park it in case you have a lot of obstructions in your field. So these are the location. If I know the location, I can drag and drop the location here, or if I want to get the open position, I can put it into 180, or I can actually use this dial here to tune in. If I don't want to open it all the way, I can put it 30 degrees, and I can do that right here. So once I have configured the chamber, I can decide how to estimate the flux. So in the flux tab, I can pick up the flux block here. The flux block is where you will give out specifications on how to compute the flux. Here we can specify the dead band, the stop time. So that's where we will do the nonlinear curve fit to estimate that initial slope, which will be used to estimate the flux. So once you have the flux block here, you can select your gas. So in this case we have multiple gases from multiple gas analyzers. So I can use this for methane. I can duplicate this and do one more flux check estimate for CO2. Here I can also have a different dead band or a different stop time. Duplicate this again and have CO2 from the 870 which we added. So in one chamber we can get 3 different fluxes, and this flux tab basically configures how that flux fitting is done. So once you are configured the flux tab, we need to set up the measurement sequence, and that is done in the sampling sequence block. So here we can decide how to do the sampling. Do we want to do it continuously, or we want to repeat this in a certain interval? We can also decide how to do multiple replicates here. So I can choose to do 15 minutes, 30 minutes. Usually when you're doing co-located measurements with a flux tower, you may want to do 30-minute averaging, 30-minute fluxes. So once I have configured that, here is where I will say if there is any interruption to the sequence, what to do. If you stop at a particular sequence, should you continue with the measurement, or should you go to the next port, or you start over from beginning. So that those three options are here. We can just go with whatever sequence was happening, just continue with that. So now I have to configure the observations. So I go to sampling sequence and I pick my observation block, and I have to make sure I choose the right port here, which is port 8. So this is basically telling that I have a sampling sequence where I will make an observation on port 8. If I want to do one more observation on the same port, I can go to the sampling sequence and add one more block here, and I select the right port here. So now you can see automatically my total time is updated, because the first measurement was 120 seconds with 15 seconds pre-purge and 15 seconds post-purge. So now I have two such measurement sequences. I can add a delay to this from the sample sequence. After the first measurement, I can have a delay between or afterwards. I can do this in different ways, so that the device pauses for in this case 30 seconds between the observations. Now you can see that the green button is enabled, and I'm basically ready to start the measurement. So in this case, what will happen is at the beginning of a 30-minute period, so which will be like a 30-minute from the hour or from the half an hour, we'll start a measurement, and we will do the first observation, wait for 30 seconds, then do the second observation, and then the sequence will be waiting for the next for the 30 minutes to elapse, and then repeat this continuously. I can add different sensors to my chamber. So from the sensor library, I'm going to add a Stephens probe, which we added to our chamber, and I can configure the sensor address and the parameters I get from the chamber. Multiple sensors can be added to the same chamber. I can also add light sensors to the same chamber and configure it. So once I have configured my sensors, the verify button should be green, and basically the configuration is in the device. I can check it, no issues are found. So let me take some more time to explain the configuration tab here. There are a few more buttons here. We have the load, the save, the reset, and the verify. The verify is basically telling if the configuration is fine. You could have a configuration built like this, and then you can save that configuration. The save button basically saves it to your computer. So you can see it just downloads it to my download folder here, and that I have this config.mux file is there with me. It's basically a text file which has that current configuration. Now if I want to recreate this configuration from scratch, without pulling down all these blocks, for example, if I'm just going to reset, reset will just totally reset this entire configuration window, and I will delete everything. And I want to load that old configuration back, can go to the load. I can pick that config file I downloaded from my downloads here, open it up and load it back to the system, and then it will recreate that entire configuration just like I saved. So this is another useful feature where I can send the configuration to different collaborators or save it for future use. So here I have a setup where I have connected the multiplexer to an 870 and a 7810. So I can see those in my configuration here, or in my device network here. The device network and my configuration are interlinked, so if I move things out from here, it also moves away from my device network. So you can see right now it's connected here. If I go my configuration, I delete this gas analyzer, go to my device network, you can see the 7820 is present, but it's not connected to the system. I can drag and have it connect here in this way, and when I go back to my configuration, the 7810 gets automatically added to the configuration. There are a few more things you have to be careful when you are setting up a measurement. The volumes and the tubulums have to be entered in more accurately. You can always go back and correct them in SoilFlux Pro, but here you can make those changes. Regarding the observations, the way we compute the observations, the flux observation depends upon the amount of flux you are expecting or the nature of the soil you are working with. The nature of the trace gas you're dealing with also determines how long you will take a measurement. For example, if you're dealing with a very porous sandy soil where the flux rates are high, you may want a shorter observation interval, like maybe even a minute. So maybe you can do that in a 60 seconds. If you're dealing with clay soils where the flux rates are much lower, you may want to go 2-minute observations. Now if you're dealing with saturated soils where methane, you're looking at methane emissions, you may want to do observations for longer periods, maybe even 3 or 4 minutes. Similarly, with trace gases like N2O, which are coming in episodical or pulse events, in those cases you may want to go with a longer period, but then when you expect increased flux rate because of a rain event or something like that, you can always pre-process the data, post-process the data, sorry, in SoilFlux Pro, and you can look at the fluxes for shorter intervals of time also. So before we set up the measurement, you can also view a chamber and the data coming off the chamber by using the active ports here. I can connect directly to the chamber and I can look at the data coming off the chamber before I set it up in the field. So this is one good way to make sure that the chamber is working properly. And I can go to my manual controls and then open and close the chamber from here. That's only possible when I have my ports selected here. So this is an important thing to keep in mind when you are checking your system before you make a measurement. Some other settings to keep in mind: network. This is an important setting when you are especially setting up for remote access. So if you are setting the system with a modem, you may want to give it a static IP address. In that case, you may give a static IP address which is matching your modem settings, something like 192.168.13.206, which works for a Sierra Wireless modem. And you here also will specify the gateway in that case, 31. So this is such settings will enable you to have the remote connectivity. And with the remote connectivity, another important nice feature we have is you can push your data to a remote server. So this can be your raw data or just your summary files here. So you can push the data to an HTTPS server, or SFTP server, or an FTP server. So different, most universities will have some kind of SFTP server access, or you can actually even do this to a Dropbox account. So that is a very nice feature we have with the 8250. This does not require a public IP address on the system. The system can just push the data by itself, even with a private IP address. The diagnostic tab also gives you a lot of important information regarding the different aspects of the system. For example, in this case, I can look at the diagnostic information from the 7810. I can look at cavity pressure, face pressure. If there are any issues, I will see this kind of a red warning sign. In this case, I have an issue from this 8250, which indicates there's a problem with the GPS. Right now the system is sitting inside, so I'm not seeing satellites, hence the GPS data is not coming in. I can go into the details and see all the data coming out of the chamber. So this gives a snapshot of what is happening right now with the chamber. Similarly, I can also get information on the chambers themselves, or all the gas analyzers connected to the system. In this case, we have an issue with the SDI-12 sensors because that sensor is not communicating properly with the chamber. So once the measurement is started, as the measurement is happening, I can see the various variables showing up on the screen. I can plot the pressure. I can have the flow rate. I can also have readings from the different gas analyzers, like the methane data. If I want to plot those variables, I can click on them and they will show up in the graph here. I can plot up to 2 variables here on the graph. If I want to switch to a different variable, let's say pressure, I click on one of the variables and then I select the next variable you want to plot. And since it's a web-based UI, if you navigate away from this UI, the graphs will get reinitiated. The data from the chambers are visible as long as the measurement is happening, and if not, you have to go and select a port where you want to examine, and then only you can plot the data. So now we can go out there and set this up and take a measurement. So before we go to the field, I just want to show you one more last thing, how you can download the data from the system. We can go basically to the Files tab. Here I'm going to download some data which I have collected earlier. And here you can select a start time and an end time. So let's say from February of this year, 18th to April 8th. So the system will show you the raw data and also the summary data. So here I have 2651 raw data file. Each file is a single observation from a single chamber, and then I have the summary files. I have the buttons here to download or delete the data, or to transfer those measurements to an USB if I have a USB drive inside the 8250. I can also select a summary file and plot, for example, the methane concentration in that file. So this is for one particular day. This is summary file. This has data for the entire single day. I can plot multiple variables, up to 2 variables. If I had to plot a third variable, I have to uncheck the first one and select the next one. I can plot the flux also here, and understand the patterns before I download it and take it to do the analysis. Once I click the download button, the file will be downloaded to your computer and it will come as a single zip file, and that single zip file can be directly uploaded into your Soil Flux Pro software for further analysis. So right now we have the chambers all set up in the field. I have the long-term chamber here. Ideally we have to pre-install the collars at least 24 to 48 hours before we take the measurements, so that the disturbance in the ecosystem is gone by the time we start the measurements. Once we have the collar here, we can take our chambers and we can put the chamber around the collar in such a way that we form a good seal around that collar, and we can adjust the chamber legs so that we have a really good seal between the collar and the chamber. Okay. So once I have that good seal between the collar and the base of the chamber, I need to estimate the distance from the soil surface to the chamber itself. So to that I have to basically take a measurement from the top of the surface to the top of the collar, and subtract that from the base of the chamber to the top of the collar. So I take two measurements, one from the base of the chamber to the base of the collar, and one from the base of the soil surface to the top of the collar, and that will be used as the chamber offset, which we'll put in the software. Once the chamber is set up, if you have to add any other sensor like the moisture probe here, you can attach to the chamber and then insert it directly right next to the chamber, so that we can estimate the soil moisture at the measurement site. So once you're set up with the chambers, you can set your multiplexer upon some wooden planks so that it's elevated from the surface, or you can use an enclosure like this to protect it from the solar radiation and the elements. Now we are ready to start a measurement sequence. Now that I have connected my phone to the multiplexer system using the Wi-Fi, I can start the measurements right from my phone here. So I go to the home page and I can click the start button here to start the measurement sequence. So this concludes a basic measurement with an LI-8250 system. We do have more materials and videos on website. If you have any more questions, please feel free to contact us or our distributor in your area.